Hey guys, welcome to Learnix. In this video, we're going to be covering the types of numbers HCF and LCM. This comes up constantly in IGCSE, so let's get into it. Okay, so regarding types of numbers, there are a few. Starting with natural numbers. Okay, natural numbers. Natural numbers refer to all the common everyday counting numbers that you use, as in 1, 2, 3, 4, 5, and on and on and on. Okay, zero is not a counting number because have you ever counted, oh, that's zero apples? You don't do that, right? You count that's one apple, two, three, four. Exactly. So, zero is not a natural number. Moving on to integers. Now, integers are basically numbers that are natural numbers, but negative numbers and zero are included. They're all whole numbers, by the way. Natural numbers and integers, they're whole numbers. So, example, -3, -2, -1, 0, 1, 2, 3, and on and on and on. Okay. Uh, Decimal points are not included. Okay, so 3.4 would not be an integer. Zero is an integer, negative numbers are integers as well as positive numbers. Okay, that's simple enough. Now, prime numbers are numbers that are divisible by 1 and itself. An example of a prime number is 2. 2 is divisible by itself and 1. Okay? Another example is, let's say, 5. 5 is divisible by itself and 1. Right? So all the numbers that are divisible by itself and 1 are prime numbers. Okay. One thing to point out is 0 and 1 are not prime numbers. Okay. Moving on, we have square numbers. So think of natural numbers 1, 2, 3, 4, 5, but you take the square of each number. So that would be 1, 4, 9, 16, 25, and on and on and on. Okay, that's basically the square of natural numbers. All right. And same with cube numbers. They're basically natural numbers, but just the cube of them. All right. You can try to find these out yourself. They would be 1, 8, 27, 64, and on and on and on. Okay. These are cube numbers. Now, uh, just a quick heads up. This topic is going to be there for core and practical students, right? So it's essential that both students, regardless if you're taking core or extended, you know this. Okay. Next up, we have rational numbers. Okay, and basically these are numbers that can be written as a fraction, such as a over b, right? Or 22 over 7. Okay. Now, one thing I would like to clear up about 22 over 7 is that many people think 22 over 7 is equal to pi. It is not. Okay, 22 over 7 is an approximation of pi. Okay, uh, pi itself is not a rational number. It is infinite. Pi has infinite decimal points, is what I meant to say. Pi is not infinite. Pi is 3.14 blah blah blah. It does not have an end. Okay, it cannot be written in a fraction. So pi does not equal to 22 over 7. 22 over 7, as you can see, is a fraction, so it's a rational number, right? And another thing, if you have, let's say, 6.6766767, don't do it, 67 recurring, this is also a rational number. That's because the decimal places are recurring. Okay, now we have irrational. Another example would be surds. We have discussed already about pi. Irrational because uh, the decimal points are non-terminating and they don't repeat. Okay, they don't repeat. Uh, Another example would be surds. Surds are a great example of irrational numbers like root 2. put in root 2 into your calculator, you're going to get a massive ugly number with a decimal point and never ending numbers after that. That's basically what an irrational number is. Okay, now moving on to our final type of numbers, which are reciprocals. Okay, reciprocals are basically, uh, you can say, just flip a number upside down. So let's say 4, right? 4, normally you would represent it as 4 over 1, right? You take any number, let's say 5 is represented in fraction as 5 over 1, yeah? So when you're taking the reciprocal of the number, just shift that upside down. So the reciprocal of 5 would be 1 over 5. That's basically it. So reciprocal of 4 would be 1 over 4, okay? Now moving on to HCF and LCM. All right. Now HCF, also known as the highest common factor, is basically, it's kind of self-explanatory. It's the highest common factor of two numbers. So let's go with 12 and 16. All right. Now write down the prime factors for 12. 12 equals to, let's make a tree over here. Okay, the factor tree. So we have 2, we have 6. 2 in itself is, you can't have factors of 2 because it's a prime number. Then we have 6, which can be done as 3 into 2. I mean, of course, you could write 1 into 2. You have 1 to 3, and you have 1 into 2. Now, write down all of the factors, right? So we would have 2 squared because we have 2 twice over here, and then we have 3. Okay, now if you solve this, you would get 2 squared 4. 4 times 3, you would get 12. So these are the prime factors for 12. Right, now let's write that down. 2 times 2 times 3. Let's do the same thing for 16. Okay, we have 16 over here. What are two numbers that multiply to make 16? 4 and 4, right? Then we have 2 and 2, right? And then in front of that we have 1 and 2, right? We have 1, we have 2, we have 1, and we have 2. Okay, so how many 2's do we have over here? We have 1, 2, 3, 4, right? So it would basically be 2 to the power of 4 equals to 16. Input this into a calculator, and I'm pretty sure you will get 16. So 16 equals to 2 times 2 times 2 times 2. Now, uh, remember what we talked about earlier, the highest common factor of two numbers? Now, take a look into the factors of 12 and into the factors of 16. What is the greatest number that you can see is present in this and in this? That's right, we have 2 appearing 2 times over here. We have 2 appearing 2 times over here, right? So this equals to 4. This equals to 4, right? So our HCF of 12 and 16 would equal to 4. Okay, let me okay, now let's move on to LCM. All right, LCM is the lowest common multiple. Okay, I'm sure you've heard of this concept. Let's take the same numbers, 12 and 16. All right, now we know that the prime factors of 12 is 2 times 2 times 3, right? And we know for 16 it's 2 times 2 times 2 times 2, basically 2 to the power of 4. The lowest common multiple would be the lowest number that is present in the prime factors of 12 and in the prime factors of 16. And in our case, that's 2. So the LCM of 12 and 16 is 2. All right, now let's move on to some past paper questions which I have actually taken screenshots of and attached into this file, right? So lowest common multiple of 36 and 48. right? Now, one way we can do this is using the prime factorization method. It is super quick and easy. All right. Now put 36 and 48 into a bracket over here and find the smallest number that is divisible by both, which would be 2. 2 divided by 36 would give us, take a guess, 18, right? 2 divided by 48 would give us 24. Now, again, smallest number that divides into both of these, it's 2. This gives us 9 and this gives us 12. All right. Now, let's do 3 over here so that we get 3 and 4, right? Now, these two don't have a common multiple, so basically uh, we can write 3 over here, we'll get 1 and we'll get 4, and we write 4 over here, and then we'll get 1 and 1. Okay, now the numbers we have on this side are all the prime factors of 36 and 48. So to find the LCM, we basically take all these numbers and multiply them together. So it's going to be 2 times 2 times 3 times 3 times 4. Answer is 144. Right? Okay, moving on to our next question. We have a list over here, and from this list of numbers, write down a factor of 15. All right, so what's the factor of 15? Let's list down factors of 15. All right, we have 15, we have uh, 5 times 3. Let's check. There it is, 3, right? So we write down 3. Now a multiple of 18. Okay, let's write down multiples of 18. We have 18, 36, and look at this, 36, 36, already found it. Okay, an odd squared number, right? Now remember the square numbers: 1, 2, sorry, 1, 4, 9, 16, 25, and on and on and on. Let's try to find an odd number from this. We don't have 9, 16 is not odd. We have 25, 25 is not given. Let's continue. Next number is 6. 6 squared is 36. This is not odd. The next number is 7. 7 times 7 is 49. Let's check if we have 49, and yep, we have 49 right here. 49. Next, a cube number. Cube numbers. We know that cube numbers are 1. 2 to the power of 3 would be 8. 3 to the power of 3 would be 27. 4 to the power of 3 would be 64, and 5 to the power of 3 would be 125. All right, now let's try to find one of these. Yep, we have 27, and that's an easy 4 marks right there. Okay, now write down 45 as a product of its prime factors. Now remember the trick we just used? Okay, that's not straight. 45. Now lowest number that divides into 45, 5, right? What does that give us? This gives us 9, right? We have 3, it's going to give us 3, then we have another 3 to give 1. So 45 equals to 5 times 3 times 3, and if you put this into your calculator, indeed you're going to get 45. So 5 times 3 squared. Since 3 is occurring 2 times, you can write a square. Now find the HCF of 45 and 105. Okay, so HCF we can use the same method, but we need to modify it a little bit. All right, so let's make a long line. Again, 5. This gives us 9, and 105 divided by 5. You can do it on your calculator. It's not a big deal. It gives you 21. Now divide these two by 3, gives you 3 and 7. Look at here. 3 and 7 do not have a common factor. Okay, so we're not going to continue. Take 5 and 3 and multiply them. 5 times 3 equals to 15, and that's your answer. 15 is the HCF of 45 and 105. That's an easy 2 marks. Okay, hope you understand. That's all for this video. In the next video, we are going to be going into powers and roots. See you there.